Hello student, today I will continue from the last class. Last class I have started molecular orbital theory M.O.T. Now I am continuing conditions for the combination of atomic orbitals. Last class I told you that just like molecules, atom combines to form molecule, like that way here it is also there. From the atomic orbitals, molecular orbitals forms and number will be the same. If two atomic orbitals are mixing, then they will make two molecular orbitals. One will be bonding molecular orbital, another will be non-bonding molecular anti-bonding molecular orbital. Bonding molecular orbital and anti-bonding molecular orbital. Then now what are the conditions for the combination of atomic orbitals, that I am going to discuss. The linear combination of atomic orbitals to form molecular orbitals takes place only if the following conditions are satisfied. Some conditions are there, three conditions are there. It must be satisfied. First, the combining atomic orbitals must have the same or nearly the same energy. This means that one s orbital can combine with another 1s orbital, but not with 2s orbital, because the energy of 2s orbital is appreciably higher than that of 1s orbital. This is not true if the atoms are very different. Second, the combining atomic orbitals must have the same symmetry about the molecular axis. Symmetry must be the same about the molecular axis. Symmetry means just like a structure you can do. By convention, Z axis taken as the molecular axis, it is preferable. It is important to know that atomic orbitals having same or nearly the same energy will not combine if they do not have the same symmetry. It must be same symmetry. Even they have almost same energy, they must have the same symmetry. For example, 2px orbital of one atom can combine with 2px orbital of the another atom, but not with 2py or 2pz. 2py or 2pz orbitals, because of their different symmetries. Symmetry must be same. 2px they can do, 2py they can combine, 2pz they can combine, but not 2px and 2py, not 2py and 2pz. Third condition, the combining atomic orbitals must overlap to the maximum extent. They should overlap in maximum extent. More, they should overlap more. Greater the extent of overlap, the greater will be the electron density between the nuclei of a molecular orbitals. Now I am going to discuss types of molecular orbitals. Just like different type of orbitals are there, S, P, D, F. Like that way here, types of molecular orbitals are there. Molecular orbitals of diatomic molecules are designated as sigma and pi orbitals. Sigma, pi or delta orbitals. Generally these three are there: sigma orbital, pi orbital and delta orbital. In this nomenclature, the sigma the symbol is the same, just like a 6 I told you. In the nomenclature, the sigma molecular orbitals are symmetrical around the bond axis, while pi molecular orbitals are not symmetrical. This is the difference. Sigma molecular orbitals are symmetrical around the bound axis, while pi molecular orbitals are not symmetrical. For example, the linear combination of one s orbital centered on two nuclei produces two molecular orbital. Here it is important things. The linear combination of one s orbitals centered on the two nuclei produces two molecular orbitals which are symmetrical around the bond axis. Both are symmetrical. That's why they are overlapping and they are making molecular orbitals. Such molecular orbitals are of sigma type and are designated as sigma 1s. First orbital name is just like ordinary orbital. We are writing 1s, 2s, 3s like that way. Here what is the different? Then you should write before 1s sigma, you write sigma. That is only different. Either you will write for bonding molecular orbital you will write sigma, and for the anti-bonding you will write sigma star before 1s, before 2s, before 3s. This is the different. And same way for p you will write pi, just like we were writing 1s square, 2s square, 2p6, 2p6. Then here before the 2p you will write pi, and not pi, pi you will write before 2p6 or 2px, 2py, 2pz, whatever be, you will write pi. Okay, pi for 2px also pi, and for 2py also pi, and for 2pz also you have to write pi. Just before px, py, pz you have to write pi. And same way for nt you have to write pi star. All things are same like ordinary orbitals. Only here before the orbitals, for the s you write sigma, and for the p you write pi. That is the difference. Now I am discussing ahead. Then it is designated as sigma 1s and sigma star 1s. That is for anti-bonding. Always there will be first bonding you have to write, and then immediately you write sigma star you have to write. Okay, as for example sigma 1s, and then you have to write anti-bonding 1s, sigma 1s and anti-bonding 1s. Okay, then I have told about the molecular orbital. Two molecular orbital, first sigma 1s, then other anti-bonding sigma 1s. Now again listen, important things. If internuclear axis is taken to be in the Z direction, Z direction, it can be seen that the linear combination of 2pz orbitals of two atoms also produces two sigma molecular orbitals. Correct? It also produces two sigma molecular orbitals designated as sigma 2 px and sigma antibonding sigma 2px. Okay, again you listen this point. If internuclear axis is taken to be in the Z direction, then what will happen for the y and x and y? Then it is related to that. If internuclear axis is taken to be in the Z direction, it can be seen that a linear combination of 2px orbitals of two atoms also produces two sigma molecular orbitals designated as sigma 2p z and sigma 2p z. Sigma 2p z or anti bond sigma or sigma antibond 2pz. When you are considering for the z, then you have to write z. When you are considering for y, then you write y. When you are considering for x, then you should write x. Then if you can say internuclear, if internuclear axis is taken to be in the z direction, it can be seen that a linear combination, linear means always sigma. It can be seen that a linear combination of 2pz orbitals of two atoms also produces two sigma molecular orbitals. Okay, when they are linear, only in that situation, and it is designated as sigma 2px or bonding. You write bonding 2px. Then bonding means sigma 2p, not the x, z. We are considering z. Then sigma 2p z and anti-bonding sigma 2p z. Bonding sigma 2p z and anti-bonding sigma 2p z. Molecular orbitals obtained from 2px and 2py orbitals are not symmetrical. See, very, very important things. Only for 2pz it is symmetrical. For 2py and 2px it is not symmetrical. Then they will make pi bond. Molecular orbitals obtained from 2px and 2py orbitals are not symmetrical around the bond axis because of the presence of positive lobes above and negative lobes below the molecular plane. This is the main reason. Again I am telling you, molecular orbitals obtained from 2px and 2py orbitals are not symmetrical around the bond axis because of the presence of positive lobe above and negative lobe below the molecular plane. Such molecular orbitals are labeled as pi and anti-pi. A pi bonding molecular orbital. A pi bonding molecular orbital has a larger electron density above and below the internuclear axis. Here again important point is there. A pi bonding molecular orbital has larger electron density above and below the internuclear axis. The anti-bonding molecular orbital has a node between the nuclei. Node means no electron density. Okay, that's why it is called node. Now then here I told you pi is used for 2px and anti-bonding is used. Here also this for bonding pi will be used, and for the anti-bonding pi star will be used. Pi star. Okay, pi always a star means anti-bonding. Maybe S, maybe P. The energy, now I am going to discuss the energy level diagram for molecular orbitals. Actually this I will send some photographs, only then you can understand. Okay, I will send the this photograph in video. Then now here some little things you should know, that we have seen that 1s atomic orbitals on 2 atoms form 2 molecular orbitals. This you should understand. Atom and atom, more than 2 atoms they are making molecules. Okay, in general you know. But here what is the difference? If 2 atoms are combining and they are making molecule, then they will make 2 molecular orbital, bonding and anti-bonding. Okay, this you keep in mind. Then here just like 1s atomic orbitals and 2 atoms for 2 molecular orbitals designated as sigma 1s and anti-bonding 1s. These are the 2 molecular orbital, bonding and anti-bonding. This sigma 1s and anti-bonding 1s. In the same manner, the 2s and 2p atomic orbitals, 2s means 2 electrons and 2p means 6 electrons, total 8 electrons. 8 electrons means 8 atomic orbitals on 2 atoms. If you suppose in any atom like oxygen, 2 plus 8, 8 will come 1s square, 2s square, 2p4, 2p4. Then 4 plus 2, 6 plus 2, 8. Okay, the 2s and 2p atomic orbitals, 8 atomic orbitals on 2 atoms give rise to the, you can say, 8 molecular orbitals. When 8 atomic orbitals are combining, then they will make 8 molecular orbitals. That you can see in a diagram. Okay, I will send it. And here very important things I am going to tell you, that anti-bonding molecular orbitals, already I have, so last class I have sent the diagram. They will be up and down will be bonding. Down means less energy and more energy means up. The anti-bonding molecular orbital has more energy and bonding orbital has less energy, and in the middle parent orbitals. Okay, because when they will form molecular orbitals, then anti-bonding will have more energy. That's why it is shown up. Same two molecular orbitals condition I am talking about. When they will have more energy, then this suppose two atomic orbitals are there, and they will make two molecular orbital. And this molecular orbital, bonding molecular orbital will be down because its energy will be less, and anti-bonding will be up. Okay, this you can see, and in diagram, if you will see, you will find just like a sigma bonding. Sigma B means sigma bonding. Sigma A means sigma anti-bonding. Then I told you sigma A plus sigma B, that is for bonding, and negative sign is for anti-bonding. For two atoms A and B, sigma A. For the other atom, sigma B, for B atom. Then sigma A plus sigma B, it is bonding, its energy will be less. And sigma A minus sigma B, that is the anti-bonding molecular orbitals, its energy will be more. Then I told you for anti-bonding molecular orbital it will be up, and down will be bonding. Then in diagram you will see these things only, and again both condition it will apply, plus and minus. For the bonding, plus sign will be there, both orbital symbol will be there, and in the middle plus will be there. Okay, and for anti-bonding same thing, in the middle of the both molecular orbital negative sign will come. Okay, then you by this things diagram you can understand all the things. Now another important point I am telling you, anti-bonding molecular orbitals, just you can write like this. I told you a star sign you have to write, a star sign, sigma a star or pi a star. Then again before going this I will discuss these things, but before that one thing you should understand, that this I already told you, 2s and 2p, 2s 2 electron, 2p 6 electron, total 8 electrons. Then for 8 orbitals, for the 8 orbitals, 8 molecular orbital will be there, that I wanted to tell you, already I told. Now anti-bonding, now come to the anti-bonding means star, sigma star 2s, sigma star 2px, sigma star 2s, sigma star 2pz. In P only Z is in a symmetrical way, then that will form only 2pz will form sigma, 2px 2py they will not make. Okay, for that pi, anti-pi is used. Then anti-bonding 2px and anti-bonding 2py. And for bonding what we will write, molecular orbitals for bonding, then it will be sigma 2s, sigma 2pz, and pi 2px and pi 2py. For bonding no star, for bonding no star, for anti-bonding star, correct. And for pi bond P is used, term P is used for and for sigma bond sigma is written. For S sigma and pz also sigma, but px and py pi is used. Then for anti-bonding always you write a star, and for bonding no star. Then for bonding molecular orbitals you can write like sigma 2s, sigma 2p, 2pz, and pi 2px and pi 2py. Then now, just like in atomic orbitals, electrons bear filling by following the above principle, Hund's rule, Pauling exclusion principle, all rule will be applied here. The energy levels of these molecular orbitals have been determined experimentally from spectroscopic data for homonuclear diatomic molecules. Homo, same atom, okay, like S2, N2, O2. Then here I was telling you the energy level of these molecular orbitals have been determined experimentally from spectroscopic data for homonuclear diatomic molecules of second row elements. Listen carefully. Second row elements of the periodic table. The increasing order of energies of various molecular orbitals for O2 and F2. For that only for O2 and F2 that increasing order of energy has been given for various molecular orbitals for O2 and F2. Okay, this you understand. Then what is this energy level? Electron will enter first in 1s, just like filling of electron in atoms, like that way. Only sigma term you have to use, sigma or anti-bonding sigma and pi and anti-bonding pi. Only that term you have to use, and first they will enter in the sigma, then anti. Then this you keep in mind. Then sigma 1s is less energy. Sigma 1s is less than anti-sigma 1s. S is completed. 1s is completed like that way. One anti-bonding 1s is less than sigma 2s, and sigma 2s is less than anti-sigma 2s, and anti-sigma 2x is less than sigma 2p z. Okay, 2s is less than sigma 2p z, and sigma 2p z less than both px and py, means both are equal, means 2p z is less than pi 2px, that is equal to 2py, and that is less than anti-bonding. After the bonding, anti-bonding will start. Same way, only anti-bonding you have to use. The term anti-bonding you have to write, means pi anti-bonding 2pz, pi anti-bonding 2pz, that is equal to pi anti-bonding 2px, and this is less than sigma anti-bonding 2pz. Okay, that I have told you, but here this order is not following, is not correct for the remaining molecules like Li2, Be2 means lithium, Li2, Be2, B2, C2, N2, all are the molecules. Okay, for instance, it has been observed experimentally that for molecules such as B2, C2, N2, etc., the increasing order of energy of various molecules orbital is where it is changing, then only all things are same, only it is changing that pi 2px, pi 2px is equal to pi 2py, what I told, that reverse case here. Only in the term of pi 2px and pi 2py is less than sigma 2pz. Sigma 2pz, that is the only difference. All things are same, because that time you have written first 2pz is less than sigma 2pz is less than pi 2px is equal to pi 2py. But here it is a reverse. Pi 2px is equal to pi 2py is less than 2pz. Other things are same. The important characteristic feature of this order is that the energy of the sigma 2pz molecules orbital is higher than that of pi 2px and pi 2py. That is the only difference. Today I am stopping only here. Next class again I will continue. Thank you.